Hi everybody. We're back for another week of remote learning. I can't believe we're getting so close. We're already into May. This is it seems like a long year, but now it's short. So I don't know, it's going fast now, and it always makes me sad as I get close to the end of the school year. I hope you guys are continuing to learn a lot and you keep working hard, and make sure you get your work done in a timely manner and hand it in on time. I know that it gets harder once it gets sunny and warm outside, but I know that you will keep working hard and go out this the last of this school year nice and strong. So we're going to start with, we're going to continue with Module 14. We're going to be on Lesson 2. We're going to be joining parts of the same whole. So we're going to be continuing with our addition of our fractions. So I'm going to get our everything set up and we will begin. So make sure you have this packet in front of you so that way you can follow along with the work. And again, we're going to be joining parts of the same whole. So basically what that means is our denominators are going to be the same. So we're going to have the same, our whole is going to be broken up into the same number of pieces, but the amount that's shaded or the amount that's needed will be different. But the whole will be broken up into the same amount or the same pieces. So we're going to use fraction models to solve problems and describe joining fractions with like denominators. Terrell is making berry muffins using the recipe shown. How many cups of berries does Terrell need? So if we look at our mixed berry muffins, I can see right here we have strawberries that are needed and blueberries that are needed. And if I look at the rest of the items, milk, biscuit mix, sugar, oil, eggs, it doesn't sound like those are berries, right? So we just want the strawberries and the blueberries. So for strawberries, we need 3/6 cup. I'm just going to write the information we need down here before we do the work. And we need 2/6 cup of blueberries. So we need to figure out how many total berries, or how much total berries Terrell needs. So if I were to show my thinking with a picture, I might start with, here is my whole, and then how much is my whole broken up into? If I look at my denominator, they are both broken up into sixths. So my whole is broken up into sixths. Now with 6 being an even number, I can break this into half, and then each side I would just need 3 pieces. And I try to make them as close to the same size as possible, as I possibly can. So each part is 1/6 of our whole. And I want to shade in for my strawberries and my blueberries. So I know I need 3/6 cup of strawberries. So I'm going to shade 3 of these in. I'm just going to use a highlighter so you can see, but you can just use your pencil. That's fine. You don't have to go fancy with a with a highlighter. But if you have colored pencils or something with you, you are more than welcome to do that. So here are our strawberries. And then our blueberries, we need 2/6 cups. So I'm going to use blue for our blueberries. And here are our blueberries. So if I just look at my picture, I can see that I need 1, 2, 3, 4, 5, 6 berries. And if I were to write this as an addition problem, 3/6 plus 2/6 equals 5/6. And that matches up, right? Remember, when we add, our denominator stays the same because this is a label. They're out of the same whole. So the whole is sixths. Our whole is broken up into sixths. So that's why when they talk about the same whole, we are keeping our denominator the same. It's almost like this is a label. Just like if I were to say 3 berries plus 2 berries equals 5 berries, it's the same idea. 3, 6 plus 2, 6 equals 5, 6. Okay? And then it would be 5, 6 cup of berries for our label. But I want you to be noticing that when we add, our denominator is essentially our label. It's the part of the whole. And because both of them are with 6, it's easy to add them together because they have the same, they're broken up into the same number of pieces, the same whole. Okay? All right, let's move on to our next problem. So now we're doing some more baking, and a recipe calls for the amounts of brown sugar and white sugar shown. How many cups of sugar are needed? So we can see that the brown sugar needs 3/8 cup. The white sugar needs 2/8 cup. So again, we've got our whole, and then we've got them, they both are broken up into eighths. So I'm going to go in half. Then if I do it in half again, and then in half one more time, that's going to give me my eighths. So 1/8, 1/8, 1/8, 1/8, 1/8, 1/8. So there should be 8 of them, right? 1, 2, 3, 4, 5, 6, 7, 8. Now, I need to shade in my 2 different types. So my brown sugar is 3/8 cup. So I need 3 of them. So this is brown. And then my white sugar is 2/8 cup. And this is white. Okay. Now, here's what we're going to do. Again, I've explained this before, but I just want to do it again. We're not going to write sentences. We're not going to. We've been explaining how this works, right? We can explain that we know that we have 3/8 for brown sugar, 2/8 for white sugar, and we're just going to combine them 2 together, right? We're going to join the 2 pieces from each fraction and solve our problem. So I would rather just jump down to letter C, and we're going to write our we're going to write our addition equation to model the total amount of sugar needed. So we know we needed 3/8 brown sugar plus 2/8 white sugar, and that's going to equal 5/8 cup sugar. Okay? So again, sometimes this program is really wordy and it wants a lot of writing of words and reading of words. And here we can let's just get right to the math. We can explain it by talking about it better than writing sentences down. You're going to forget that anyway. So let's just notice that 3/8 plus 2/8 equals 5/8. Okay? Sorry, that may be a little, I have to zoom this in a little bit. Sorry about that. So 3/8 plus 2/8 equals 5/8. Okay? All right, now we're going to the step it up part. So a recipe calls for milk and oil. So we're doing 2 liquids that we're going to be putting together. Terrell measures the milk and the oil as shown. He then pours both into a mixing bowl. How many cups of liquid ingredients does Terrell now have in the bowl? So we're going to write our equation to model the situation, and we're going to use C for the total of cups of liquid in the bowl. So here is our milk. So we can see that each part is 1/6. So we've got 1/6, 2/6, 3/6 is where where the line of the milk goes. So we have 3/6 milk plus, we can see the line goes at the 1/6 oil equals C. Remember, they want to just use the letter C for our variable for our cups of milk. Okay, so now we're going to use fraction models and join together the same size pieces to find the total amount of liquid ingredients. Draw a visual representation of our problem. So we can just use the same type of idea we've been using, where we have our one whole, and our whole is broken up into sixths. So we go in half because it's an even number, and then each side would get 3 pieces. And each part is 1/6. And our milk is 3/6. And our oil is a 1/6. Okay. Now we're going to rewrite our equation and replace the C with our answer, with the total amount of liquid. So we have 3/6 plus 1/6 equals 4/6. So that's how much liquid, or how much of the liquid ingredients Terrell needs, or he has in the bowl right now. 4/6. So, and we could say cup of liquid. Okay. Alrighty, let's go to our check for understanding. Laura walks 3/10 mile on the first day and 2/10 mile on the next. How far does she walk during the 2 days? Draw a fraction model to solve. So our whole, and this time it's going to be broken up into tenths. Our denominator is tenths. So again, it's an even number, so I can go in half. But then I need 5 on each side, right? Because half of 10 is 5. 1, 2, 3, 4, 5. So I need 4 lines, but 5 pieces. 1, 2, 3, 4, 5. And each piece is 1/10. And the first day, she walks 3/10 of a mile. So this would be day 1. Day 2, she walks 2/10 of a mile. So when I add my 3/10 plus my 2/10, I get 5/10. So Laura walks 5/10 of a mile in the 2 days. Okay. All right. Let's move to the on your own part. So remember, when we get to this section, if you want to pause the video, do this independently, and then come back and check your answer, that is more than okay. Or if you just want to stay right with me, do it with me, and then come back and check after. So Marisol is playing a game with the spinner. If the pointer lands on yellow or green, she wins. What fraction represents the part of the spinner that is yellow? what fraction represents the part of the spinner that is green? So she lands on yellow or green, she wins. So we need the fraction of the spinner that is yellow first. So I'm just going to write the word yellow with a little equal sign so we know how many are yellow. So I can see there are 2 pieces yellow, but we need to know how many total pieces there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 2/12 are yellow. And then what fraction represents the part that is green? So I'm going to write green. So again, I see there are 2 pieces of green, and I know the total is 12, so 2/12. So what fraction of the whole spinner would allow Marisol to win her game? Our explanation is just going to be our math. Let's just show the math, and that can be our explanation. So 2/12 plus 2/12 equals 4/12. So 4/12 of the whole spinner would win her. If she were to, 4/12 of the spinner would let her win the game. Okay? So here's our explanation. Instead of writing 2/12 and then the word plus, 2/12 and then is equal to, right? We can just write it with the symbols instead of using the words. Okay? So a lot of times when it says explain, if you just show your work, that is perfectly fine with me. I just want to see the work. I don't need the explanation in words. All right. Tom eats 1/8 loaf of bread. Dana eats 1/8 loaf more than Tom eats. Julia says Dana eats 2/16 of a loaf. Is Julia correct? Well, no, she's not, right? What did she do wrong? She added the denominators together, and you're not supposed to, right? So no. So here's where we would need a little explanation. No, she added the denominators together. And then to justify the reason why we know you don't add the denominators together, I'm going to draw a model. And I need eighths. So I'm going to go half. Half gives me fourths. And then half again gives me eighths. And I'm not going to write in the 1/8, 1/8, 1/8, 1/8. I'm just going to shade it so I know that each one of those is 1/8. So 1/8 plus 1/8 equals 2/8. And you're not supposed to add the denominators together. All right, and then we're going to complete these 2 equations. 3/10 plus 5/10. See how I'm saying, how when I'm talking about label, that's exactly what I mean. 3/10 plus 5/10 equals 8/10. Which if we were to draw that as a fraction, or write that as a fraction, it would look like that, right? 1/3 plus 1/3, 2/3. And if we were to write that as a fraction, it would look like that. All right, so I would like you to do 14.2 independently. And when you are finished, the front and the back of that, make sure you get it to school to me. All right, I hope you have a great rest of your day, and I will hopefully see you soon. Bye.